specialist on animal husbandry mechanization, ICRCAE in Bhopal. So rapporteurs are Dr. Astos Pandirwar, scientist ICRCAE Bhopal, and Dr. G. Sinde, head SMPE Parmani. So first I would like to invite Dr. S.P. Singh sir, project coordinator, to take care of the chairman. Welcome sir. Then I request Dr. Astos Pandirwar and then Dr. Sinde to present the report here. And this session, the lead paper is presented by Dr. S.D. Pandirwar.
Instead of Sinde, SM Nalawadi is here from.
Yes.
So you please make that change. Is he coming? No. You have to take the.
Dr. S.D. Pandirwar, former Director of Research, MPKV Raguri. So the application of mechatronics, drones, AI and robotics for precision agriculture. I welcome Dr. Pandirwar sir also.
Warranty.
Sorry.
The chairman, Honored Vice Chancellor is joining, and I thought he said he will not be delayed, so he will join. And we have the lead doctor, very well experienced, because we did not have any person from CE. He is working all around all disciplines. Warranty is the former Director of Research, LPK Lahori, and he worked as the head agriculture engineering, irrigation and drainage, basically on the caste project was his main achievement, and good cause to the all the applications which you have seen here, drones, AI, robotics and everything. He has a big team, and
I welcome Honorable Vice Chancellor Dr. Indramani sir to chair this session. Welcome sir. Sir, this session is mechatronics, drones, AI and robotics, including solar powered equipment. So there are more number of papers are there. There are 32 papers listed. So already people have loaded the presentations. So this is floor is yours, sir. Thank you.
in fact, you are lucky, sir. Actually, seeing is another year, and since you are busy, the number of papers are more. So you have to.
I will listen to.
And Mr. Kumar Vimal, he is the Vice President in National Tractors. He is also here as a special guest for this session. And he wanted to know what is new going on in farm machinery. So, welcome, I welcome you from the office. Yes.
Thank you, friends. Very warm welcome. Thank you, Singh. My friend and good person. All their colleagues, friends, and they joined. Very important session, but very late. So, then my turn, because you have to actually 7 p.m., 7:15 there's a beautiful cultural programs. So now challenge is to you that then you have just started finding show rather than dwelling upon the main things. So we start with application of mechatronics, drones, AI and robotics for agriculture. You take 5-7 minutes. Because your lectures have been, people are listening very frequently.
Okay, fine.
So you just quickly, pass on and tell the things so that the investors can, get an opportunity to speak. Great.
Okay.
Yes. You all know that you are Director of Research at Ravi University, a very laborious and very intelligent person. I have a very long association to work with him. He has been with me for my drone policy, committees always one person Brahman at night and depended upon you. Let me tell you, many times we kept meeting at 12, 11 p.m. in the night and continue up to 1 a.m. something like that many times. Because he is also very busy person. I'm also sometimes busy, so we used to find common time. So we have to learn this serious. We have many lot you can learn from. I personally feel very, very cool, no ego, nothing, lot of achievement, better research, down to earth, hard working, and I wish that he gets more opportunity because he is very young person, very young person. Actually, it looks like he has come to join service.
Thank you very much. Honorable Vice Chancellor and Chairman of this session, Dr. Igor Sir, thank you very much for nice words. In fact, we are very good friends as well. So, naturally, friend plays a friend. Thank you very much. Co-chairman, Dr. Igor Sir and Dr. Singh Sir, and the co-chairs, and also the convener who is sitting here, another my good friend, Dr. Uday Kodge. The topic is on drones, robotics and AI. In fact, this topic is quite vast, but maybe as already instructed by our chairman sir, I don't have more than 5 to 7 minutes, and that's right because the younger scientists, they need to be provided more opportunities. In fact, in 2018, we organized 54th annual convention of ISC in Pune, and Dr. Irmani was the president actually. Okay? And the international symposium was on this particular theme, drones and AI applications. Okay? I think that was probably the beginning of application of this AI robotics and drones in agriculture. And over the period of these 5-6 years, we see a lot of transition because there are almost 10-15 posters on these technologies, and at the same time, I think there are more than 20 plus presentations. So this is good change actually, and this is required. Okay, so I think much of the credit goes to our Bhishmacharya in drone, Dr. Irmani. He is heading almost all the committees at the national level as far as the application of drones in agriculture is concerned. And besides that, I think all are experts because all of you are presenting the papers, but notably I would like to take a few names. Dr. Dilip Kushwaha, I don't know whether he's present here. Then Dr. Sachin Nalode and Dr. Rao. They are really working on the application of the drones. Can you basically, all we are experts, so we need not to differentiate between the drones and other devices. But as tractors, if we attach or develop the attachment to the tractors, then only we can use for the tractors for the farm operation. Similarly about the drone, because many times there is misconception that drone can do anything, but it is not like that. We know that we need to develop the attachments, okay, and the protocol when we want to use the drone. And there is a lot of research work which is needed for this purpose, and we all are from the research community. There are various uses of the drones actually, and when I have gone through all those posters, then I found that many they are already addressing all these what we call as the applications. I have written here potential applications right from cross spraying, which is a major application of the drones, and then cross spraying is both for nutrient and also for chemicals, then seeding, bird scaring. So this is the application of the input part, but at the same time we can use the drones for artificial intelligence wherein certain decisions are required to be undertaken. We can identify, forecast and forward many things, and those are already listed here. We can estimate crop coverage, identify biotic stresses, crop growth monitoring, crop yield assessment, soil characterization, crop insurance and biomass estimation. We can do plenty of the things if we develop the proper technology. which is drone assisted actually. And I think this is the potential for this agricultural engineering group to work for the drone. And I'm quite sure, and our chairman sir will also agree that drone is probably the future of Indian agriculture, because the speed at which we are going under the leadership of our Honorable Prime Minister, because many times there are technologies, but the government, they come later, but in case of the drones, the government, they are on the forefront, and they want to use the drones for all the agricultural applications, most of them, and this is our duty that we should do all those applications. With potential benefits, there are many what we call as the challenges. Flight time and range is one of the challenge currently. But then somehow by doing certain variation, we are addressing this life cycle of the battery. Maybe this is not our issue, but that is the challenge. There is certified combinations of the chemicals and nutrients, as all of us know that on a direct basis, the CIB and RC, they have approved this, but then that licenses will in fact no more valid after 1 year. High initial cost is there, connectivity is the problem. The land holding, this is probably the thing which we need to address properly, land holding, because of the small farms. When we use the drone, especially for the spraying, and because of the drifting, we do not know in future there could be some conflicts actually. And when we develop the appropriate spraying mechanism for the drone spraying, then we need to take care that there is no drifting, and there is the spray drone mounted sprayer can spray just whatever over the width of the soil only. Then of course training institutes, and those are no more now what we call as the challenges. There are, I think, VNNKV as what we call as the drone training center. Rahuli has the RPT and many other universities as well. Then out of many applications, I will just try to highlight the drone spraying. Drone spraying has really various benefits which I have listed, and maybe I want to read that. All of us know that. But one thing is that if you use the drone spraying, it promotes the attractive farming and digital farming. Yes, and there are plenty of the advantages of this drone spraying actually. The question arises many times that what kind of the drone we should use for the agricultural spraying, and almost conscious has been reached that we should use the multi-rotor type of the drone. Okay? And there are other types of the drone, maybe I won't go into the details, but multi-rotor type of the drone we should use, and that is what SOP, which we have prepared for the government of India under the chairmanship of Dr. Indramani, that also says that we should use the multi-rotor drone. And in case of the multi-rotor drone, there are Quadra X and Octocopter drones. Then normally we say that for spraying Quadra or Hexa, mostly Hexacopter drone we should use. And for the research purpose, wherein we mount the expensive cameras on the drone, we should use the Octocopter drone because this is more stable, and even if it fails and fall down on the ground, it may not fall down on the ground, but Hexa and Quadra it could, and our expensive cameras may get damaged actually. The classification of drone on the basis of weight is very important, and I should know that because most of the permissions they are on the basis of the weight actually. Okay, so the permissions may be for licensing, permission may be for driving permit, or permission may be for the green, red, or yellow zones. These are certain spare parts of the drone. Now let us see. Certain drone spraying protocols are there. I will talk very briefly. This is what the configuration we have suggested. We means what we call in SOP. These nozzles can be mounted on the sprayer boom on left and right hand side, or just below the propeller as well. So these two kinds of the propeller we suggested. At the same time, drone spraying protocol, because when we say that we should use the drones for the spraying, and there need to be proper protocol as well. So there are 8 steps for this purpose. And we have tested all these steps at MPQ Rahuli as well. So we may wonder that so many steps are there if we want to use the drones for spraying, but let's remember that when we use tractors for any operation, equal number of steps we have to follow. But in case of the tractor, we know that we are so much conversant with that, just thinking that there is nothing. In case of the drone as well, those who are practicing drone spraying, they also experience like this. So first we have to do GPS calibration. pre-flight checks, flight planning, input filling, then setting up parameters means I will tell what are those parameters in next slide. Ready to take up mission start, and we can also check the control efficiency of the drone spraying if we want by having this water sensitive paper installed in the field at random places. Then we also work on the endurance data because there was question that one drone how much area can cover actually. So we did some theoretical calculations, and based in these theoretical calculations, we also did certain kind of evaluation, and we found that if weather conditions are good, then in 3.5 hours 10 acres of the land can be spread easily. And maybe if entire forenoon and afternoon sessions are permitted, then maybe around 20 acres actually. I will show one video wherein all the steps which I have listed and told, they are shown visually here. First. Okay. So we have shown all the steps here, and those have been properly validated and tested, and we found that this is quite efficient process to follow this. And of course, we checks and flights because all we are the engineers, and we know that as we need to check the tractors before taking those tractor on road. So we have to check drone also before we take drone in air actually. So this is a short video which shows all kind of the steps. Then SOP was a really major issue. What should be the drone parameters, drone speed, swag, then height of the drone above the canopy, what should be the formulations. And again, we worked on all those. We in fact collected the data from 78 experiments, and it was quite huge task for our chairperson to gather all those data. But we could complete that. This is the drone spraying of onion crop. And which was done very effectively. Can come back to our presentation. Next. Next. Cost economics is a real issue, and then Dr. Sachin Narode worked on this cost economics by having various populations, and we submitted to our SOP committee as well, and that committee accepted that. Next, please. So we have listed the specifications of the drone which we use for the cost economics. All the details are given here. Next please, and then finally we found that around 400 rupees are required even if you consider per acre for spraying, even if you consider the benefits as well. And probably we have some starter kind of the thing, and they are using, and they are finding that yeah, maybe this is the cost, and they can earn out of this dose thing. Next please. Next. This is the SOP actually, which is a very important part, because those who are using drone for commercial spraying, they normally ask what we should do with the height and all those things. And type of nozzle we have specified, nozzle discharge, nozzle angle, pressure, and all these things need to be fairly standardized. One and standardized. What should be the high speed, and what should be the canopy above height of the drone above canopy. Then nozzle placement, number of nozzles, swag, and all those things. So this is fairly standardized, and as I have already told you, this standardization is on the basis of some 78 data set. But this is not the final as well, because now big universities, they are conducting the proper experiments on the drone spraying, and maybe we would like to collect those data and analyze, and then we can analyze this. So we can consider this is the add-up kind of the drone SOP. Next. Yeah. And at the same time, what should be the input application parameters? So when we discussed with our entomologist and chemist, then they told that maybe the concentration and the dose we should not vary, because that is what is prescribed, and if we reduce, then maybe bioefficacy will be compromised. So it is 1x, and the 1 is very important. At early stage, maybe 20 liters per hectare, and then later on 30 liters per hectare. Similarly, environmental parameters, that is when we should use the drone for spraying. So that is also important. So those also have been highlighted in summer and winter season, just in case of the farmers they need. But if you want the exact parameter value, then that range is also given. And I think certain mobile apps have also been developed to know whether the particular local weather is suitable for drone flying, of course for spraying or not. Next please. I think this is by Riyazam Sachin. We developed actually. So that mobile app is also available. When we have to bring drone in air, so different permissions are required. Next please. This is we should know the zones where we are operating drone. That is green, yellow, and red. Of course, green zone is permitted. Typecast certificate, the drone which we purchase should not be assembled. Actually, it is properly typecast, and you can go to DigiSky website and you will know that what kind of the drone is having the typecast. This means that this drone is permitted by the DigiSail to fly air. Then you are just like for our car, which is registration number when we purchase the drone, which is typecast, we should obtain the UIN from DigiSky. Otherwise, if something happens with the trouble, then the training is required, and then finally the permit is also required to fly drone. And of course, the permit and all those things, they are not required for the narrow drones, but the kind of drone we use for the spraying and also for the mapping, we need to have all those kind of permissions. You can go ahead. There are certain exemptions as well. And let us coming back to the next topic, robotics actually. And this is quite challenging. And when we see that, so there are a number of the papers on robotics actually. Okay. But all these papers, they are leading towards certain process actually, standardizing certain process, developing certain process for the robotic operation. And I think we also got one patent on this. Some of you might also got some patent on these things. But outwardly, these robots, they are very useful or not. But I think we shouldn't bother too much about that, and we should keep on doing all those things. And next is what exactly the robots are, and we know that robots are nothing but the machines or systems we can work semi-autonomously or autonomously. So we know that, but when we discuss with the general public, they are very fancy about the robots, and when we say that the farm operations can be done by the robots, then they are very much enthusiastic to know about this. There are two kinds of robots. One is the unmanned ground system or vehicles, UGV we call, and another is the unmanned aerial vehicle, that is the drone based. Okay, next please. Yeah. And there are a number of the operations for which we can develop the robot, and in one or other way, almost we have started to address all those operations, and few of the cases I will show you. Next please. Yeah. And of course, benefits and limitation next. Yeah. So there are so many benefits of using robots actually. So I have listed that so it addresses decision farming, enhances efficiency in all respect actually. Then it offers environmental sustainability, reduces the labor cost, it is the data-driven decision-making process, and also because of all these things, it ensures the food security. But at the same time, next please, there are so many challenges in developing the robot sector actually. It's not like drone. Drone is promoted by the government quite aggressively, but it is not the case in case of the robots. And there are so many challenges, and when we try to develop any robotic-based operation, we should know all these challenges which are technical, cost, safety, regulatory frameworks are not available, social acceptance, data management, and scalability as well. Next, please. Yeah. There are different processing involved in robotics. Robotics is not just our development of any equipment, tractor operated or power tiller operated or even drone operated. Okay, but there are so many processes involved, right from the computer vision, sensors, control systems, AI-driven model, decision support system, and computing network actually. So we need several experts when we develop the robot. So we say that let us not do this in isolation, but let us have the team of the experts not only from agriculture, and engineering, but other branches of the engineering as well. Next please. Yeah. Let's start with this. Yeah. Next please. Yeah. 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 So this is the इसका वीडियो दिखा where robots will be developed actually. Dr. Sachin can tell in a posty time certain details. Okay. So this identifies fruit, whether it is ripe or not. It eats the fruit and then it drops into the basket. So this is our in-house development. Next, please. And then certain in-house development, this is we call as the Pule Robo, and it got the prize, first prize in one national competition, and it sprays this quite autonomously. Next please, I would show the video now. Next please. Yeah, that slurry applicator is also there. We do not call this as the robot, but it is the autonomous machine actually. Next please. Yeah, so these are some pictures which we have in. So these are the certain things. These are not our development. Of course, this is from this is just an example. I have shown all what we call as this is the processes, okay, which we can do. I think before moving to AI, I would like to stop here because that will take more time. But in case of just AI, we know that is a technology which we enable machine to think actually. So that's why this is artificial learning. And ours is the human intelligence, and that is the artificial intelligence. And all of us know that we need to develop the proper libraries of the images and calibrate, validate certain neural network model. Okay? All these things we have to do, and this is of course challenging. There are certain examples, but I think it will take more time. And as Chairman Sir already pointed out that this is probably time to end. So just to conclude, there are so many things which we can do, and probably if we are successful in doing so, we may find all autonomous operation in farm. And I think at Kiviravali and maybe at NNKV, we are in a process of establishing the farm wherein all the operations will be done autonomously, some with the help of our technologies and some with the help of the industries actually. So many people they ask, so whether it is really possible or not. But I would say that it is really it is possible. And as an agricultural engineer, we have to take lead actually. There are no other engineers or disciplines who can take lead. But of course, we have to take the help of others. So with this, I think I would like to leave in here. There are almost 20 presentations, and they would like to present, and we would like to listen to this. Thank you very much, Chairman Sir, for giving me some extra time for that talk.
Thank you, friends. Actually, you all know that these, hackathons, drones, AI, and robotics, artificial agriculture are, the subjects, and all of you will be talking, and what all you will cover, but I have gone through the topics, but I'm sure that this entire young team is working hard, and this is the future of mechanization and automation. I'm really very happy that I participating in different platforms, and I'm saying that the kind of that we had in machinery section because of some reason simply thing that will be built by you because future of mechanization and automation is really very bright because of the young manpower that I'm seeing here, and many of you have that kind of orientation, thinking, training, and aspirations. Only thing is that don't talk in air, be close to the ground, be very humble, very honest approach. You can't be fooled. Your profession. That is one thing. So a lot of hard work is required. But my message, a lot of appreciation is not coming. But I defend that message that because I personally believe that institutions like CIA, IRI, all other different centers, Adarsh Kumar and we keep on discussing that future of farm power on power and machinery in this energy section. It's really, really bright. Because I'm bright because of you. I know most of you, your potential, and what is basically required is really more hard work and be very much, close to ground. What it really works. And challenge is that if you don't work on it, if you don't cast hold of it, it will be taken away by others. And I already started. I have been fighting even that why they have kept machinery different and precision agriculture. You know, how precision agriculture is different than agriculture, mechanization and automation. So all of you should say that no, it is the basic aim of mechanization and automation is precision agriculture. Many of you must be knowing that the top 20th invention of 20th century. Mechanization and automation is one of the top 20th inventions, world invention I'm talking about, of 20th century. 20वीं शताब्दी की 20 टॉप जो इन्वेंशन हुई हैं, उनमें से एक मैकेनाइजेशन एंड ऑटोमेशन, जिसने brought, reduce. Again, there was a time when 50% of the US manpower was engaged in agriculture. Now only 2% of US manpower is engaged in agriculture, and they are feeding, ready to feed the world. So this you should understand. Your power, how important you are. But full satisfaction should not be there. And don't make narratives that this is not happening, that is not happening. Don't make wrong narratives at this stage. If something is not coming, feel that there is some weakness, there is some gap, and you have to, and come out with some technology. Small, which clicks, disruptive one, which is spread. Farm, not for just paper. Work for farm, not just market. And let me tell you that I politicians here, but my satisfaction, I derive satisfaction when I'm doing some academic work. We don't derive satisfaction in sitting in vice chancellor activities, and I'm still connected with all different platforms, Rajasthan study here in guiding students here, different other fields remaining connected to that. And I know the work of most of you because of different evaluation, different platforms, different things. But my only section is no full satisfaction. Hard work is required, and if hard work is there, other days people were telling you are not us. I'm not known to anybody in ministry, but they have made a standing committee that all these part government you are mentioned that 10 crops का ला दिया, अभी बाकी crops का फिर से लेके आना, फिर ये भी आपको खराब लगे, फिर इसको भी improve कर सकते हैं. So 5 success now last committee is on uses of drone other than spray. That is big one because that they want to do the hunting etc. So drone will be the first one, which will be very much required and will come in use. Government is behind it as a volunteer was set, pushing, pulling all efforts. And that's why successively in 3-4 years 5 committees there, 5 committees. And it was science-led policy, making and policy decision. And government has now realized that don't give policy making of science to civil servants. Give it to scientists. That's how we brought even industry together. Dr. Kumar Vimal is here. And first decision when this was given, we took that industry should be brought together. And if we are making SOP or some industry, we must consult that industry. should not be that totally unacceptable. I've recently been given a responsibility to develop policy on GEM pipe, and all other members are from industry. And one scientist, they start, but chairman they made scientists. So I'm telling you, that is the realization. That's another moment. So one thing is very clear: if you are working hard, people will be behind you. But work hard means complete, accomplish, submit, and say yes, it is done now, and rest, the other things. So two things only. You have a lot of potential, very bright future of agricultural mechanization in the country, only because of you. Those notes, and I'm not talking about infrastructure, fund, all these are least important. What is important is manpower. कुछ भी पैसा आपको दे जाए, कुछ भी इंफ्रास्ट्रक्चर जाए, कुछ भी बिल्डिंग दे दी जाए, कुछ भी चीज कर दी जाए, अगर आप काम नहीं करना चाहते तो कुछ नहीं सकते. तो you make the difference. You will make the difference. I'm very confident. And 10 years ahead, machinery mechanization will be totally changed in India. Totally changed in India. Only because of it. I wanted to basically spend 2 to 5 minutes on you, so that people, I was thinking that to call a meeting of investors, all investors of machinery and power to discuss, but I think there will not be time. So this is the platform I'm using, that lot of belief on you, lot of faith on you, lot of potential in you, but uphill task is there. People are there, they are claiming drone is mine, robotics is mine. So, now that you have to start. And only way is the hard work. Only way is the performance. Hard work, performance, and the other one is smart work. A smart worker is one who accomplishes. Hard worker is one who does hard work whether the result is coming or not. So you have to become a smart worker and give small or big technology to the nation, so that OCI investors can do, IRI investors can do this, and all other different universities, investors can do it. अभी उस नैरेटिव से काम नहीं चलेगा, मुझे एग्रीकल्चर इंजीनियर हूँ तो मुझे ये काम तो ये था, तो गवर्नमेंट चाहेगी जैसे काम कर पाएगा उसे आप कर सकते हो तो करो, टाइम के अंदर कर सकते हो तो करो, नहीं कर सकते हो तो they will give those responsibilities to someone else. And the first detrimental effort was to divide machinery and energy one, and precision agriculture different. So I think very important thing, and I now let us proceed. And you all know that time is very short, so the next one is thank you, Rasa, for giving this. I will request that continue your effort to guide, become mentors for them wherever it is possible. Next. Okay. Sunil is my student. He was a student at IRI, and he did masters. He was doing PhD with me, but suddenly he left because he became the youngest assistant professor at his university. Right? Yes, sir. So Sunil, you what? It will be science, no? Saying that I feel tell us some convincing thing that one can accomplish.
Before we start the presentation,
अगर किसी का कोई brief questions हो मुझसे या डाक्टर वॉलंटियर से तो वो भी बीच में आप
I would like to request those who have not visited Rahuri Card Center, wherein we have the labs of drone robotics, AI/ML, sensors, and aspect imaging. They can visit. Most of you might have visited the drone center at BNMK, but we also extend invitation for Rahuri.
I don't know, did you visit Nayak Center? Did you take the tour?
Yes. Yes.
Another thing I just want to add, if you want to really do on this thing, don't do alone. We have made here policy and company. We are working with 4-5 drone industries and come together work, including we are doing custom hiring. First center we have opened custom hiring of drones, and a lot of farmers, they are coming forward and we are doing that job, custom hiring. I don't know exact address, but we did a lot. Then 6-month training program we have started. RPTO we have started. Recently we signed a MOU with Daksha, and then research work will start in addition to this RPTO and training program. So if you want to succeed in this, in new areas, try to engage and involve industry. Because industry, if they are involved, they will not do fluffy thing. They will do exact practical, which is going to generate money, generate fund, and create acreage, create hectare, and create influence and impact. So this year I have made policy that we will work with industry, not alone. So how many industries are working with our drone industry?
Drone, 5 industries are there, and out of which
We have in 8 districts we have a number of centers. So we have in Maharashtra Agriculture Technical School. They are dying. Many of them are already dead. We want to revive. The Agriculture Technical School, we are bringing drone, robotics, skilling, training. My IMA team visited our Marathwada, this Maharashtra Mechanization Center. Some of them, wonderful investment from industry, complete, and with us they are working on skilling of the farmer. So one mantra, and that's why in the whole conference I am keeping him beside me, that without industry in agriculture and mechanization, you cannot create impact. So this one thing if you try, then only you are going to succeed. And Director CIA is here, and a great man in mechanization, and then our PC Payam is here. They are more basically accomplished and knowledgeable person. They will agree that what I am saying, concept of commercialization in other areas it is possible, but in mechanization and automation, industry association is must. If you want to make impact, उसमें आपको दोनों के इंटरेस्ट अलग है. आपका बिजनेस इंटरेस्ट नहीं है, उनका बिजनेस इंटरेस्ट, तो कॉन्फ्लिक्ट ऑफ इंटरेस्ट नहीं है. तो काम आपको जो भी अकम्प्लिश होगा, एकेडमी का पूरा क्रेडिट आपको जाएगी, और उससे अगर कोई बिजनेस क्रिएट कर रहे हैं तो हो जाएगी. एंड वी हैव हियर अ सिस्टम, रेवेन्यू जनरेशन इज आल्सो देयर. इन ऑल दीज एक्टिविटीज देयर इज रेवेन्यू जनरेशन. व्हाटएवर वी विल कम, 25% will come to us. The latest MOU will be applied,
with our government resolutions.
and then government is ready to give money. Until unless you are there, government is not ready to give money. So they will take some, if an industry is ready to come if you create ecosystem for that. So some Dr. Borantiwar has also done. I am requesting the gentleman Gopal Sende is here, because Nayab PI, and you should take the team to also find some time.
Yes.
Quickly and show what we are doing in drone, particularly this new thing after closure of Nayab. What we are doing after closure of Nayab.
We are executing experiments and drone.
And friends, there are number of schemes in Maharashtra. We have Sarthi or what are Sarthi, these are fellowship there. You get that fellowship for training those people. Alright, this gentleman is working with us. They both are working with us. इनको भी जॉब मिला, इनको भी अपॉर्चुनिटी, ये भी अपने बच्चे हैं. इसीलिए लोग आएंगे इसमें. आप में से कोई अपना स्टार्टअप खोलेगा, इंडस्ट्री इंस्टीट्यूशन के साथ मिलकर के काम करेगा. प्रैक्टिकल चीज करनी है जो अगले 2-3 साल में इम्पैक्ट देगा. प्लीज स्टार्ट.
Very good to all. So myself, Dr. Sunil Shiva, working as professor at US Raichur. So today I am going to present about the performance evaluation of UAS spare for managing insect pests in BT cotton ecosystem. So as already we know that cotton is one of the major commercial crop in our country, and also it is one of the
crop which consumes maximum amount of pesticides for its cultivation. So that's why again we have seen that in major news articles also we have found out that because of the exposure to the chemicals by the farmers, so many issues has been done, and it has been, the study has been also conducted in, survey has been conducted in Karnataka, and we have found out many issues in our leading days, that is regarding the cancer, death, and presence of pesticide even in the blood content and urine content once they have been completed the spraying operation. So to just to have know that, so our main intention is to is there any possibilities to reduce the recommended dosage? What are the recommended dosage is there as per the university?
That is actually all of you requested to just tell the accomplishment. Rest and other things are no reason. Just accomplishment. What is your delta S? What you have added to the knowledge of this area? We understand that you have prepared your presentation, but good thing should be that you just tell this much I have added to the knowledge of drone or AI or this and that. So your work come exactly to your work.
So in this study we have compared three sprayers, the drone mounted sprayer, knapsack sprayer, motorized knapsack sprayer. Then this is the treatment which has been done. That is the chemical which has been used is a combination chemical. There is a dinotropyram and diaphenethrin. So which as per the recommendations, it is recommended around 625 grams per hectare. So where we have conducted experiment at different dosages at 25% less than the recommended and 50%, and also we have taken the double the recommended dosage and recommended dosage with the knapsack sprayer and motorized knapsack sprayer.
What was your conclusion?
So we can reduce the chemical content.
We understand now, servant also understand. What was your conclusion? What was your finding? What was your finding?
These are experiments which are conducted, and we have done the phytotoxicity study also, and we have also seen what are the effects are there on the natural enemies, because this is the doubt in our university also they have been having, so that's why we have conducted this experiment. So this is the bioefficacy study that has been done for the treatment whatever we have done. So where we can see in the with the seventh treatment, that is uncontrolled treatment, comparing with this. So in all the treatments, so at 50% less than the recommended dosage, there is no reduction. Reduction is around 50%, and as we are increasing, it is coming around 59 in at 25% less than the recommendation, and at 100% it is around 59%. So with the power sprayer and also with the knapsack sprayer also, with the power sprayer it is coming around 59%, and with the knapsack sprayer it is coming around 40%. So here we can see, even though we are reducing the chemical less than 25%, then also there is no significant difference in the controlling of the thrips in the cotton crop. Similarly, the leaf upward was also effect on the leaf upward has also been conducted, and similar results are also we have got for 25% less than and recommended dosage.
Conclusion.
So no phytotoxicity has been observed for this insecticide application. So this is the effect of the natural enemies. So here in natural enemies, actually there is a, you can see in the copulated adults and Cyrosclera adults, so there is a significant effect on these things, but when we talk about the spiders, it is having the same effect as that of the knapsack sprayer and the motorized sprayer. And this is what the BC ratio, the cost of operation and BC ratio has been calculated, where we got a better BC ratio and similar BC ratio for 100% application as well as a 24% less than the recommended dosage applications. So finally we can conclude that, so even with the less than 25% of the recommended dosage can be applied for the insecticides in the BT cotton, where we can reduce the chemicals. So which is going to be, you can say, the price of chemical can be saved by the going for the drone spray. And there was no effect on the natural enemy population, and also no phytotoxicity symptoms were also observed in the studies.
your conclusion, you also mentioned what speed you are recommending and what
Yes, sir. Actually, that study earlier it was conducted, sir. So I have
come with that.
yes, sir, it is there, sir. I have shown this.
Then
The condition of the crop and environmental conditions should be there, otherwise,
in conclusion,
In conclusion.
another question is why your BC ratio even for chemical application they don't say.
Sir, that is again the similar yield has been obtained, sir, here. A little bit.
low yields are there.
The yields are going down.
Yes, sir. If you are going for less than 25% recommendation, the yield has
I am
been.
asking only about 25% as the recommended. The BC ratio is more or less same.
Yes, sir. It is around coming 2.60. Yes, sir. It's almost same, sir.
Almost
Similar.
same. So
BC
why-
ratio we are obtaining.
Why it is so? Because 25% chemical is anyway same.
Yes, sir. We have taken that one. It is costing around 10,620 rupees. Chemical cost.
So actually 1,000 something is same.
Sir, the difference is because of this yield, sir. Here, a little bit amount of yield is more, sir, in this section. That's what this is the same BC ratio we are obtaining.
And we cannot recommend like that. And you can't recommend like that. If you are sacrificing it with the sacrifice of the chemical, then you cannot. So there may not be significant.
But there is no significant difference among the yield also. But
also not there.
yes, sir.
Numerically,
Numerically, it is little bit changes. That's why in calculation part.
numerically it is lower.
You see the statistic. You analyze it statistically. You analyze it statistically.
1 year experience is enough.
1 year experience.
At least you continue for 3 years.
Yes, 1 year experience.
और एक्सपेरिमेंट के लिए
Next.
नेक्स्ट ओंकार गुप्ता आर यू हियर आएंगे आप
सही निर्माण
थर्ड सही निर्माण
इमरान आप हो गया. Mark over 5 minutes. Yes.
चलो आप ऐसा भी कर सकते हैं कि डिनर के बाद भी मिल सकते हैं अगर आज ही खत्म हो जाए.
एक सेशन कल के लिए वैसे ही बचा दो. दोनों बचा हुआ है.
वही कह रहा हूँ डिनर के बाद फिर से मिल सकते हैं.
Good evening, sir. Myself Dr. Sajid Kumar, Presenting Development and Evaluation of Remote Control Tractor Vehicle for Small Farm. So this development is basically to have a small. Yes. So this is our vehicle which is developed 9 kilowatt. So here the vehicle is an unmanned vehicle which can be remotely operated. And this vehicle was developed to neglect the small vehicle problems like treachery involved, like vibration transfer, noise involved in the small tractors or small vehicles. So we developed this unmanned system where the person is not there, the safety will be ensured. Apart from that, we have a system like that, engine, track type system, implement attachment system, and also hydro electronic system in the unit. So I will go, these are the different components in the unit, and these are the different components we fabricated, designed and fabricated for the unit. And these are the different chassis unit and complete unit. And here I go with this one where the system is having a electronic units which is electro hydraulic system where the receiver will be the remote control, the transmitter will be the remote control, and the receiver will be on board on the vehicle. So it will be used for control of the vehicle. So I will go here. So this is the actual vehicle. Yeah. This is the vehicle, sir. You can see all the operation was remotely done, which is a direction front, reverse, turning left side, turning right side, this not only helps for driving the vehicle, but also this is useful for attachment of implement like lifting, lowering, and also for any road. So here safety, and another one is track type vehicle. It will be have a more stable in the hilly region or also on the small areas. The vehicle width is 70 centimeter, which is useful to work in between 3 feet crop, and also it will be useful for rotary weeding and also for different planting operation and also seed bed preparation. So this is another video where we have given video while practically we are working with the system. The other side we can't able to say for turning the vehicle. Similarly, like our car reverse camera, we have given a camera attached to the front of the vehicle so that we can have look on the other side and we can take it. So that is the practical problem we observed on the vehicle. Accordingly, we have given. Apart from that, we have given an emergency stop system. For example, any person comes in front of the vehicle or some animals or even one in the distance of 50 centimeter, the vehicle will stop even if you remotely actuated or anything. So this you can see it is done in the field, how depth it is working in the field. So we have observed that the system is working very fine up to the depth of 20 centimeter. And practically it is going very well, and we have taken a pivot turning. In the same point we can take, so small form problems can be overcome with this vehicle where no need of headlamp is required. So here I want to show the pivot turning, sir. So remotely the lifting can be done, then there remotely it can be done, then it can be rotary tiller can be off, then it can be turned like this for the second row. And this is another real problem where in between the sugar can we can't enter inside the. So weeding is really very challenge. A person will have so many injuries on his face and this. So we developed a system to work in between the sugar can, so the weeding can be ensured. So apart from that, sir, since the person is not going and that injury can be avoided, and we have given a GPS system and camera assistant system to turning and also observing where the vehicle is inside the field. So this is taken with the camera. We have taken how it is working in the field. So this is again we have developed so many, not only the implement but so many attachments so that it will reach commercially to the farmers and use it will be useful. So far we have developed planters, weeder, rotary tiller, and we are also developed a detection based spraying system, and we are in process of developing 2 more attachment with this unit, sir.
Do you have some, you have studied how much is required, how much?
Yes, sir. We have studied for the vehicle. Yes, sir. Sir, we have calculated force.
How many hours you have operated?
Sir, so far the running of the vehicle we have taken more than 50 hours, sir. And for the power rating for vehicle is 4 HP, sir.
How many hours continuously?
Continuously.
15 hours means so many hours. Yeah. Really continuously, how many hours?
So free run, since vehicle we developed, the free run was done for 8 hours with the Sugarcane Breeding Institute for complete 1 day with the help of Sugarcane Breeding Institute director. We have tested recently for whole day, sir. Since we are having testing center, we tested whole field up to 8 hours, sir. Yes, sir.
What is
Sir, yes, sir. There is data, sir. So many things will be come here, but we have developed what is the power rating for driving the vehicle. We have calculated which is 2.8 kilowatt needed, and what is the power rating when we have attached rotary tiller, planter, and everything we have calculated, and we have the data, sir. And accordingly, we have only 12 HP track powers engine. Yes, sir, we are trying now with the transplant also. We will come up in 1 or 2 months, sir. We are trying it because since it is a track type vehicle, we are trying with wetland also, sir. Yes.
Track type is not important for industry. This track type is better if it can work on the wetland. India,
yes, we are focusing that, sir.
Wetlands where the tractors are heavy.
Yes, sir.
And the 4-wheel tractors are really not working.
Hmm.
Like you have seen track type combines and
Yes, sir.
Friday in
Yes, a combined harvester, track type combined harvester.
India only track type thing on wetland.
Yes, sir.
Thailand, you have tractors with,
Yes.
right? So the real value of this.
In hilly area and also wetlands, sir. Yes.
Yes. So even in hilly areas, you will have a challenge because to lift it from one step to the other step is always a problem. The weight would be there.
Similar to our power tiller, we have to transport it, sir. But since there is safety is ensured, sir.
But if you can work them with the wetland, I mean, it can be.
We are working, sir.
It can replace all your power tiller and the weight.
It has already been planned, so it is moving one step by step.
So far the stage is not come to display here, sir. We are working on that.
This is very interesting.
But he has done good.
Yes, that's what I'm saying. It's very interesting, very local food.
Sir, for small information, the design was, this is design registered already. It is in process, and the government of Tamil Nadu chief engineer has visited to see this unit, and they are requesting for inclusion in subsidy scheme, sir.
Weight कितना है?
Sir, इसका weight 150 kg है, sir. अभी.
With engine
With everything, sir. With everything.
150
150, sir.
and length.
Length is 70 feet width and the length is 1.3 meters, sir. 130 centimeters. Very small size. Look like here, but it's very small. Our director has already seen it.
Weight is interesting.
Go ahead.
So this is the last conclusion, sir. So far we have tested the machine which we have developed tractor vehicle, and it has we have seen the driving of direction, speed and everything was very good, and turning we have achieved even 90 degree and 180 degree turning was very good, sir. And ultimate attachment we have tested with planter, wheeler, and also now we recently tested with sprayer also, sir.
Imran, you have already clicked.
Yes, sir. So thank you, sir. This vehicle definitely will ensure the safety of the person, so there is will not be a problem of accident or injury. Thank you.
Next. Next is Vishal Dasrath Rao. और बंदे विशाल लीड संतोष कुमार आनंद गौतम संतोष हाँ चलो भाई देश के हिसाब से इसका हो आज आप जल्दी जल्दी ठीक रहेगा
गुड इवनिंग सर
उधर में है
इधर जाएगा ठंडा
आपसे नीचे बैठने का
इसलिए पीछे बैठे
गुड इवनिंग सर माय नेम इज डॉक्टर संतोष कुमार साइंटिस्ट डिपार्टमेंट ऑफ फार्मेसी एंड पावर इंजीनियरिंग पंजाब एग्रीकल्चर यूनिवर्सिटी हरियाणा I am presenting here my work predicting modeling for Wi-Fi control in cotton crop, assessment of different spraying effectiveness using PM, ASA and ANN model approach. So cotton is the most important the study was conducted to evaluate the various spraying technology like high frequency spray, air assisted drop-off type, automatic gun type, air assisted, engine power, knapsack spray, manually operated knapsack spray, UAV spray. So these are the picture of different spraying technology evaluated in cotton crop. So for the evaluation of the spraying, three important parameters, droplet characteristics and bioefficacy and cost of only was considered. On the basis of these recommendation evaluation parameter, high clearance spray machine produced the highest large size of pollinated DOD, and drone spray are producing the less size of droplets and less number of droplets per centimeter square coverage, and deposition is also as compared to manually operated and electrostatic and tractor operated sprayer like automatic high clearance and air assisted drop-up sprayer type. So finally, this is the conclusion of different spraying treatment for the control of whitefly by using the approximately this 100 gram active VI per hectare. So white fly detection after 10 days, maximum white fly reduction at 10 days was found in case of electrostatic sprayer 77.9%, and in case of drone sprayer 73.14% white fly detection was observed. However, the almost all spray perform reduce the white fly significantly before to after the spray. And this is the prediction model. This is the scatter diagram, actual versus predicted. So ANN model same produce as the white fly control as compared to the white fly control as the drop.
संतोष जी निकला क्या वो?
Yes. Finally, here assisted boom. This is the conclusion slide. Finally, droplet characteristics. Here assisted boom spray higher droplet density was observed in high clearance spray boom. Largest size of droplets with the highest percentage coverage area, and UAV spray produce lowest number of droplet density and coverage. Bioefficacy significantly reduced from the before and after. And here assisted electrostatic spray reduce maximum number of whitefly population. And yes sir.
सबको पता है पहले से 20 साल से 30 साल से यही सब पे डिपेंड करता है, कोई स्पेसिफिक रिकमेंडेशन होना चाहिए।
ऑप्टिमाइज किए थे उसको ऐसे कि एक रिड्यूस हो रहा है बिना एक बढ़ रहा है। हां तो यू हैव टू ऑप्टिमाइज इट।
थोड़ा ऑप्टिमाइज करिए,
ऑप्टिमाइज सॉल्यूशन।
ऑप्टिमाइज जो है आर स्क्वायर वैल्यू आपकी बहुत कम है,
थोड़ा उसको देखिए आप,
ओके
इस पर और वर्क करिए। गुड, थैंक यू।
मेघा विजय कुमार,
कौन प्रेजेंट करेगा?
सतीश, सुनील शेरवा, आनंद जैन, हरीश नबी, वंजा बी वेंकटेश, राथी नेवल,
किसी के 2-3 पेपर
राती लेवल है।
प्रेजेंट कर देना काम मोर देन वन पेपर।
आप सभी लोग ना पहला स्लाइड दिखाएं, फिर आपका मेथोडोलॉजी की मतलब वर्क क्या है एग्जांपल तीन स्लाइड स्टार्टिंग नहीं तो फिर आप लोग यही देखोगे फिर आप।
Warm good evening to all present here. Myself, research scholar at TNU, Coimbatore.
known, your name is written.
This is the overall methodology I have followed. I have collected soil samples from the selected experimental field and executed soil sampling process, and based on the soil test crop response equation that is already published by the soil science department. The fertilizer dosage has been calculated, and based on the soil sampling, variogram maps have been developed, and based on that maps and the fertilizer dosage calculated from the STCR equations, fertilizer was applied. These are the equations that are available for the paddy crop and the Irrigur soil series that is available on the experimental field. In this nitrogen, potassium and phosphorus dosages were calculated, but granular urea application for nitrogen has been done in this study. For development of maps, that is a variogram, 9 combinations have been done, and based on root mean square error value, best combination was selected for each nutrient, and field application was done through UAV with the developed and select best fit variogram, and after application of the fertilizer at the active tiller panicle initiation stage, the field was evaluated with the multispectral drone. And these are the soil test results. And these are the developed radiograms for 5 different nutrients, that is NPK, DC and pH. And
carry on. They are calling me. So finish as early as possible.
They are ready actually. 7 o'clock was decided and 8 o'clock.
आधा घंटा और बढ़ा दीजिए, हम लोग आ जाएंगे। वो तो कल 10:30 तक करते ही रहे और उतना तो लगेगा ही, 7:30 तो लगेगा ही, बट 7:30
and
It is in convocation hall. And dinner is in Indradhanush.
And this is the nitrogen radiogram developed, and based on this radiogram, fertilizer has been applied. And comparing the blanket recommendation and SCCR recommended field, there was a NDVI variation within the SCCR field as 10%, and blanket field they have 64% variation. So, this was shows a positive result for the SCCR field, and comparing a blanket and SCCR field. 29% yield increase was found in the SCCR treatment. And through kriging methods, based on different kriging models and methods, best fit variogram was developed for the NPK and ECMPH, and soil test crop response based fertilizer application was done through UAV.
Okay, thank you. Dr. Rao. Okay, just one query. Are you soil scientist?
No, sir. Actually, we are applying the fertilizer through UAVs, granular urea application. Based on the
This activity has been done under active on soil test crop response.
FTCR.
Coordinated from soil
yes, sir. We have taken the for calculating the nitrogen dosage. We have adopted that their recommendations.
I'll try to save the time. Respected chair, co-chair, and other issue faculty. Good evening. I will be presenting the development of device for real-time grounded bird necrosis virus. So I would like to have your attention because the biological aspect that engineers can do, I would like to try to highlight that. We all know the effect of the disease, and out of that, if we see the GDNP, it affects 90% of the cropping tomato. So how the pathologists and others are doing it to know the severity, it leads to the diagnostic kit that in the laboratory they go for that diagnostic kit, and it takes a lot of time. It around costs 1,800 rupees to have the one diagnostic on the severity. But we know during the time of COVID, we had a simple RT-PCR kits, and we used to get to know about the virus. So from that we have developed this concept. We inoculated the GBNP virus from our own to the plants, created the database to have the 3 types of plants. There's some virus inoculated, some mock inoculated, and some healthy plants. And from that, we studied the spectral changes in different brands in the visible region and near infrared region. And for this, we have used the spectral sensor AS3741, and this is the methodology which you can see that how we inoculated and the different steps, and through the mechanical sap transportation method, we inoculated that disease in the plant to create the database. So from this, we trained that through the machine learning model, that is the decision tree model. In the decision tree model, we also developed the disease severity index, having the range from 0 to 1, indicating that how much severity is there. And from the plant pathologist, this is the scale, class 0, 1, 2, 3, 4, and 5, depending upon the severity that we have. And when we converted this spectral information based upon the disease severity, we could develop the device that's there. So with the use of this device, we can simply get to know within the 1 second that what is the severity, whether it falls in the medium, it falls in the low, and it falls in the high severity. So we evolved this device, and if you see, we evolved this and correlated with the PCR, polymerase chain reaction, the data molecular technique, and we could see that up to the 50%, that is, in the higher class, we could not get it accurate. But for all other classes, the reason for not being accurate in the last class, that is when the severity is more than 50%, it was probably that at that stage the range is too much, that is 50 to 100%. So here I would like to conclude that as an engineers we can develop such innovative tools for these plant pathologists, and now Honorable PM has started Clean India program where we need to have the seedlings free of viruses for the farmers. So that's a big program and we can contribute to that by developing such things. And for all other this like we have other disease detection, it is my thank you very much.
Thank you. Any quick query? Supriyanka, Rajwal, Dr. Devanand Maski, Sunil Sirwal. अच्छा आपका ही हुआ है। हाँ आपको पालन कर चुके हैं, कोशिश करें।
So this is the so I'm going to present assessment of operational parameters that is influencing for herbicide application to drone mounted sprayer. So already we know what is the need for the drone in the especially the paddy crops. So we are concentrated on the paddy crops. So this is the details which have been done, where the experiment has been done in the paddy crop, which is a variety of SRM 609, and these are the meteorological parameters which has been taken, and the spraying has been done by with both the pre-emergent herbicide as well as the post-emergent herbicide. And this is the speed of the drones which has been used for the spraying operation. And the experiment has been conducted in one of the research stations at US Raichur, where the pendimethalin has been used as a pre-emergent herbicide with 700 ml of per hectare dosage, and another is a commonly product, it is cyclobutyl and panaxolum, which is most commonly used for as a post-emergent herbicide for paddy crop, and at the rate of 1000 ml per hectare dosage rate. And these are the different parameters that has been studied. It is forward sprayed 5 levels, then out of spray, and the dosage level also varied from 50% to up to 150% it has been taken. And these are the different parameters which has been studied. And the experiment has been conducted to horizontal CCRI. And this is the diagram of the experiment which has been conducted, and for the measurement of the grip it has been taken up to 4 meters from the targeted area. And regarding the droplet size and density, it has been done collected through the water system papers and collected through deposition software. And the spray rate for the measurement of the spray rate, we have taken one iron bar which is having different places, that is 1 meter, 2 meter, 3 meter, 4 meter from the non-target area has been kept, and those things have been collected for determining the percentage of grip. And the weight control efficiency is also done by making a so these are the experiments which has been conducted, and phototoxicity is also measured depending upon the severity of the effect. So this is the effect of droplet size, sorry, effect of different parameters on the droplet size. And here and for the post-emergent and for the pre-emergent, the effect was similar. And ultimately, the main thing is in the phytotoxicity, it is also having an effect on the yield. Also, we have taken the yield of the crop for the different treatments. And regarding the phytotoxicity, so in pre-emergent, the phytotoxicity we have obtained up to the only number 2, that is a scale on 2. It means the crop is going to be recovered after a certain period of time. But in the post-emergent, what happened? So once you go for more than 100% of the application, so after 2 it was coming, but after 125 and more than 125, so it was going on more than 4, 5 and 6, which is permanent damage for the crop. It has been observed. and the parameter has been optimized for the service application. It is coming around 2.5 meters of forward speed, 2 meter height, and dosage level of 105. So that's why an experiment has been conducted based upon that. These optimized parameters, that is 2.5 meters, 2 meters height, and dosage level of 100% dose taken. So these are the observations. That is the reading efficiency, which has been controlled, coming around 90%, 93%. Then the velocity, as I said, it is the 0%. Zero has been observed in the scale, and application rate was 56 liters per hectare with a feed capacity of 2.9 hectares per hour, and yield was obtained around 5,500 liters. So again, the field it has been compared to the farmers practice, and this is the cost of operation. The savings in the time is maximum with already 6% has been we can save in the time.
Thank you.
So this is the final recommendation. That is the forward speed was coming around 2.5 meters per second, and rate of spray was 2 meters, and dosage level is 100%. And it is not recommended to go more than 100% because at 100%, so the damaging level is very severe. Thank you.
Thank you. Mr. R.C. Solanki.
Good evening, one and all present over here. I am going to present. Development of Android-based fuel management system for tractor. So we know when we want to evaluate the machine, any development machine.
आपने जो किया है ना वो बताओ.
Yes, yes. So for that we have to measure the fuel consumption. So we have made this effort to make the fuel consumption. Directly we can get the reading on the mobile application. So we have developed a mobile application, and we may use the sensors for this. So I just go to these are the components. So two sensors are used, one on inlet side, another on overflow side, and all the components required for the development of the system is here. These are the connections. Then we developed this Arduino IDE code. Then we developed for this code for what is the requirements we require inlet to overflow. We use the time requirements. What is the time of our test duration? On the basis of that, we can directly get the result in liter per hour or liter per hectare. So this is the set of requirements for this. So we use the Bluetooth device, and through Bluetooth device we get the reading on directly mobile application. So we need this application agri-fuel tractor made. This is the interface for development of this application. So this is the calibration. We did the calibration on the tractor for both sensors, and we find that is the MF, that is the multiplication factor, because this multiplication factor is one of the important parameters in the calibration. So we find this, and this multiplication factor is included in the code, and then the system is finally run for the in the field. So in the field we use this for calculator and AP cloud. So these are the results. So we find the multiplication factors, like these are the multiplication factors which we added in the code. This is the calibration, all this calibration. And then in the field we use with the calculator, so we get the this shows the error accuracy and this average fuel consumption. So this is the again we find that if we increase the speed, engine speed, the multiplication factor changes somewhat. So to make more accurate, we find the multiplication factor as per the engine speed, different engine speeds, and the equipment which is operating on what engine speed, according to we can feed this multiplication factor, so we get more accurate result. So you can see here we operate the calculator, suppose at 1600 RPM engine speed. So average fuel consumption by our system is the application. It shows 4.71, and actual fuel consumption is 4.40. So we get the accuracy about 92.82%. Similarly, in case of MP Cloud also we have tested it, and this is the cost of the system, that is about 3,972. So this is all about the system. Thank you very much.
One thing you can tell me, how can you reduce this, increase your efficiency?
6 to 7% is
Yes.
So how what way you can increase up to 1 to 2%?
Yeah, for this more set of calibrations are required. We are developing motivation factor for suppose 1400 RPM, 1500 RPM. So we have to reduce the range. We have to find for 1400, 50, 1400, and then we have to collaborate all these things. So we can reduce the.
Say you tested with one factor.
Yeah, one factor. Yeah, one engine. Yes.
But suppose engine group is changed. So what will happen to your Android system? But the will work for other set of
So we have tested. We are not tested for
your
this.
fuel system
Yeah.
changes.
Yeah, yes. Yes, yes.
So your
But sir, our motto is that actually when we develop a new machine and we have to calculate the number of treatments and number of readings we have taken, thus we have only top calculation time or top of time. So this will give the accurate result of the fuel consumption with that particular machine or particular factor. If we install and directly we can get the result readings of the mobile device. Okay.
you have done a good thing, no doubt. It's not, but needs a thorough.
Yeah, yes.
Based on the number of cylinders, the number of cylinder plays in
Yes, we can work on
efficiency and all that.
Yes, we will know this, sir. We have.
Okay, thank you. Next. Next, आपको सारा देखो, ठीक है, starting बढ़िया है किया।
Okay, thank you, sir.
Make it more. Yeah, Mr. Naresh. Naresh Raja. राजेश मोदी। चलो भाई चलो। अच्छा विक्रम भी हैं। इसके बाद कौन है गटकल? गटकल हाँ ठीक है। दिलीप जट भी हैं। मनोज कुमार है तो सब सीआई के ही हैं सब बड़े भी बात। सुबह करो। हाँ सुनो करो।
नहीं सर।
My topic is optimization.
आएंगे सर अभी
Ready position
दिन भर बैठे रहे सर तो पता चल
I want to show here a 2% loss. We have calibrated the drone and technical plan is this. We have taken height speed 3 level, height of spray 3 levels, spray chemical 2, and it was compared with the traditional method. And some dependent parameters were taken and weight control efficiency was calculated. So these were the parameters: 5 meter per second, 4 meter per second, 3 meter per second speed, and height was from top 1 meter, 1.5 and 2 meter, and water sensitive papers were kept, and chemicals were 2, metribuzin plus 240, and halosulfur and methyl plus metribuzin. This is the methodology in UV sprayer and knapsack sprayer. Then these are the results. It shows that when it test, it shows the I will just tell sir this combination. It was 3 meter per second and height was 1 meter. 1 meter was the good for the droplet density about 48.7 droplets per centimeter square, and coverage was 16%, NMD 94 and VMD 266 micrometer, and drift potential was 14.3. So this is statistics. It shows that speed and height was significant in all the parameters, and for the weight parameters, it was at par with the control. The best operational parameters for weight control was speed 3 meter per second and height of spray. Drone-based weight control has an efficacy of 80.2% as compared to the unrated lab, and the difference in weight control effectiveness between the drone and manual knapsack sprayer was not statistically significant. Also, we have conducted experiment in morning, afternoon and evening, but morning was more effective. These are the results I am showing you. These are the visual results before and after, and there was no hypertoxicity observed.
आपका conclusion क्या है?
सर ये conclusion
तो ठीक है। आपने ये आपका देखा great position. One thing you have seen that because you are working on sugar the insect in the roots.
Yes.
So then it will be effective to have some.
For that particularly we are doing with this plant pathologists. We are conducting that experiment. Entomologists and plant pathologists we are doing that.
You conduct the experiment even below space.
Oh.
What is happening? You have seen your data.
Yes.
Everything has come down to your lowest point.
Yes, sir.
So there is equally likely you can get better result even if it comes
Low
down.
school.
So your things are not optimized actually.
Okay.
It will come down. You have
Okay.
to do one is let us see where you are getting the best.
Okay.
Right now,
Okay, sir.
next Vikram.
Thank you.
Respected Director C.I. Bhopal, Chairman of the session, all the distinguished scientists, ladies and gentlemen. I am here to present my paper on development of spot fertilizer applicator for grape vineyard. I will directly come to the concept. Actually, C.I. Bhopal was given the task from NRC grapes to develop an spot fertilizer applicator for application of grapes near the root zone. So, in cotton, we have developed a mechanical sensing based device which was developed to apply the fertilizer at the root zone, and we have tried the same concept in grapes. But after testing our first version of the machine, we found certain lacunas, and then we shifted to the modified design of the fertilizer applicator. If you can see here, what we have done, the fluted roller mechanism is there. After fluted roller mechanism, there is a holding cup, and in the holding cup, the fertilizer is there. And then what we have done, we have used an ultrasonic sensor to detect the stem of the plant. And after detecting, we have used a stepper motor. This stepper motor, above the stepper motor, there is a rotary mechanism, and that rotary mechanism is mounted eccentrically, and there is a 4-bar mechanism which moves to and fro. Once it moves, this is the sheet tube through which, this is the fertilizer tube through which it is connected, and once it detects, it's open up and fertilizer goes down and drops down at the root zone. So this was the circuit diagram for the actuation of the system. Yes, sir. Yes, sir. So we have validated the results using machine learning algorithm, and we have used linear fine support vector machine, boosted tree and exponential GPS for that, and for all them the R-square value was more than 9, and we have validated the same result with artificial neural network. So this is the demonstration of the developed machine at NRC grapes. In August only this year we have tested, and the percolation of fertilizer through the root zone is still in the testing stage. So these are our conclusion. So now how it is affecting the yield and how it is percolating through the root zone. Now it is studied by the soil scientists at NRC grapes. So thank you.
ये जो 175% आपने लिखा है पूरे थ्योरेटिकल, या तो थ्योरेटिकल में कुछ गड़बड़ है या ये थोड़ा सा कुछ रिकॉर्ड करने की जरूरत है। ओके सर, 175 का मतलब नहीं तो अच्छा लिया तो डिनोमिनेटर चेंज कर दो आप। नेक्स्ट मिस्टर गडकर, दिलीप जाट आपने देखी रही है ना?
Optimization of the parameters for spraying with anti-aerial for sugarcane crop.
This is नहीं present कर रहे हो भाई आप।
So major reason for optimization of the parameters crop because there is different types of spray which is not effective for after some kind of crop, because sugarcane after around 2 meters after 6 months. So and there is uneven spraying. So we move towards UAV, which is more uniform spraying as compared to the conventional sprayers. So this is the material method. So we select the part after petroleum operated UAV. This is the meteorological parameters which is measured during the field evaluations. This is the layout of water sensitive paper on sugarcane crop. At after 6 months of the crop, there is a 2 meter height. So every 16 centimeter there is a attachment of water sensitive paper. So and this is the calculation of drip. This is the target zone, and this is the target zone. After target zone, the water sensitive paper was attached after 2 meters to measure the drift. This is the plan of experiment that is applied, and is 3, that is 1.5 and 2.5 meter, and flying speed is 3, 4 and 5 meter per second, and there is a 4 dependent variables where calculate and droplet density, droplet size, spray coverage and spray deposition. This is some photograph. This is the water sensitive paper collected after the spraying operation on top, bottom and middle. This is a droplet size analyzer which is used for the calculation of different. This is the droplet density which is highest at the 1.5 meter height and 3 meter flight speed, that is 97.33 and 88.33 at top, middle and bottom, and lowest is 40. Yes, that is.
उन्होंने 3 से स्टार्ट किया, वो तो 3 पे जाके रुके।
And then they ultimately conclude that 3 is best. So 3 is not best.
Even recommendation may also be 3 kilometers,
Yes,
3 meter per second.
And where is the problem?
Same, copy to you
No
also.
sir, I am doing the price review. उनसे पहले क्या?
नहीं आप
You have not less than 3 meter per second. You also, if you continue, then you go to the lower speed also and see.
He working after 1 month of proximity.
And you may get better results.
Yes.
What is the same thing for you also?
Next,
I don't think you will be having same thing.
This is the straight characteristic which is calculated from the field elevation. This is first is the target zone measure. After target zone 2 meter, 4 meter, 6 meter, 8 meter and 8 meter.
भाई मेथड आपको बताओ, कंक्लूड क्या कर रहा है वही होगा जो उन्होंने किया, आप करो कंक्लूड करो। हाँ।
My conclusion is height is 1.5 meter above the prop canopy and speed is 3 meter per second. And the spray depth is up to 8 meter because of smaller droplet size, because hollow component.
डॉक्टर दिलीप जाट वो जरूरत है, वो सारे बाहर के पेपर इसी 3, 4, 5 में ही आ गए, हमें उसमें नीचे से जाने जरूरत है।
Actually तीनों चीज को ऑप्टिमाइज देखा।
Very good evening to all of you. I am going to present my research program development of automatic spraying system for folios. In this system, the objective was to develop an autonomous spraying system for folios, and we have also evaluated this system in field. And this is our concept. Actually, we have developed 2 types of system. One is spraying system, another one is row changing system. The row changing system is to just shift from one row to another row for our automatic spraying system. And this is a system. And these are the control system for automatic spraying system. One Arduino board we have built, and DC motor and different battery and different circuit system. And another one is row changing unit. It is used just to change the row from one row to another row, just to shape our system. And these are the different control system for row changing units. And we have also developed one locking system. While leaving the spraying system, then row changing system will be in lock position. So one locking system is there. And these are the control system for spraying as well as locking system. And these are the flow chart of complete how our system is working. It will start spraying in one row, then during the return it will again go to the row changing unit, and then it will move to the next one, start spraying in another row. So this is one animation is there. And we have also evaluated this system in field. Initially we have for optimizing its forward speed, spraying distance and working pressure. So this water sensitive paper we have used for this purpose. And these are the results of the study effect of different operating parameter and droplet density So it is decreased with increase in forward speed distance and increase with working pressure. So these are the results, and finally these are the optimum parameters. Forward speed of 0.79 and spraying distance of 250 and working pressure of 0.4 megapascal is optimum parameter for obtaining the droplet density coverage, the better application rate. So we have also calculated the uniformity of spraying at different height, and there was no significant difference in droplet density was obtained in coverage also. And BMD it will increase with at top the BMD was more, at the lower it is less. So these are the results, and finally concluded that an automatic spraying system has been developed for limiting the human intervention in sector levels and
Thank you, Dr. Jha.
at point.
डॉक्टर आदर्श कुमार सर, आप कुछ पूछ सकते हैं कि आपने काम किया है।
You have to lay the track.
Yes.
How expensive it will be?
For 500 meters per polyos, it will cost around 1 lakh rupees.
So who will do the cost?
Sir, if we will add this cost at the time of laying the polygon, then it will, and the.
So will this track will be adherence in subsequent operations?
No, sir. Actually, we are using whatever the space available in the place.
आपने एक बार बिछा दिया, उसके बाद जो ऑपरेशंस परफॉर्म करने हैं क्या वो उसको रुकावट करेंगे?
नहीं सर, अभी तक तो ये सर 4 साल से हमने बिछा कर रखा है, ऐसा कोई प्रॉब्लम नहीं है। इवन जैसे हार्वेस्टिंग वगैरह में जो प्रॉब्लम होता है, नहीं सर उसमें फिर सर जैसे टर्निंग वगैरह में स्पेस ज़्यादा चाहिए, हम जो ऑलरेडी बट सर यस, जो ट्रैकिंग और उसकी रेंज की कॉस्ट है वो सेंसर और उन सब की कॉस्ट से भी कम होगी अगर एक 500 मीटर स्क्वायर का एरिया हम लें।
आप रिमोट के लिए कंट्रोल करते हैं,
बट एक बार नहीं होगा इससे मल्टीपर्पज ऑपरेशन हो सकता है।
नहीं वो क्या होता है उसको अगर आप उसको पहले डाल दें प्रोग्राम उसका सेम
दोनों लोग एक दूसरे का देख
सर एक वीडियो है अगर शो
अच्छा दिखा दूंगा
और कौन बच्चा अभी
आपने अभी कहा पर इसलिए मैं आपसे कहा सिमिलर
सर ये जैसे रोड के एंड में जाएगा ऑटोमेटिकली ये कैसे शिफ्ट करता है, इसके ऊपर प्लेस हो जाएगा और दूसरी रो के सामने आएगा ऑटोमेटिकली। तो सर एक बार ऑन करने के बाद फिर किसी ऑपरेटर की जरूरत नहीं है, ऑटोमेटिक ऊपर काम
खत्म हो गए तो
सर ये बाहर का टैंक है उससे हमने कनेक्ट किया, इसके ऊपर कोई टैंक नहीं है, ऊपर ये उसको बाहर रखा होगा। और पूरा सर एसी पावर से भी चलता है, वो जो उसका वो चेंजिंग यूनिट है वो एसी पावर है, तो ऊपर बैटरी का भी उसमें रिक्वायरमेंट नहीं है।
चलिए थैंक यू, बंद करिए। नेक्स्ट मनोज कुमार। मनोज कुमार की बात कौन है? एलप्पा अभी है, जी का
Good evening to the House. Under this topic, application of AI and machine learning in video counting and distribution of real time. So, basically, here we try to reduce the cost in crop cutting experiment that is used in yield estimation. So, by using image processing, we have some. So, basically, in our procedure, we are collecting images, then we are collecting field data, real field data, then calculation of area of real image frame using OpenCV package in Python, and training object detection model in EuroVX using Ultralytics package. So this is our methodology. We will use reference object in image that will use to find the area of that picture frame, and using object detection algorithm. We will find how many 1 year head is there, how many 2 year heads is there, and how many 3 years is there. So basically we are getting two things, and by combining these two we will find yield estimate. So this is the step for reducing crop cutting. So at the place of harvesting entire plot of any size, we use sub-sampling of 3 places, and this will drastically reduce the crop cutting cost. So here how we are calculating area of real. See, this is one picture, and with the help of this reference object, we are finding this square frame. What is area of a square frame? So the square frame area is coming 1.02 and area of whole image is 4.47 square meter. So some error is there because this square frame was not even. And we custom trained the Eurohead model for our purpose. And this is performance of our this model. And see, this is one image that have actual 132 number of hairs, and our model predict 98. So at this time, with very few hundred images, we are achieving accuracy of 74%. But we have to tune hyperparameter like confidence nanometer section over union. So we will do that. And so this is for streaming of video. So we can also use in drone to count on real time. Next one. And also we have one web. So this web recently we have put on local host. So one can upload image and right now it will tell only how many heads are there, and we are working on this estimation of area. So this website will come on local host and we have to upload any image, and this will tell how many heads are there. So it is showing 30, and we are working on this how we can find area in this. Thank you very much. Next, Mr.
Good evening to all of you. So I Lapa from Tamil Nadu Agriculture Institute, Coimbatore. So my topic is UV based aerial scientific propagation for paddy application. So this manually propagation of already knows everyone. Just what we did, I will go through the aerial propagation. So existing UV used for spraying purpose. That one we made for the customized into other two applications for seeding as well as fertilizer propagation. So first design and fabricated the functional components of the broadcaster. So 10 kg payload capacity hopper was designed and fabricated. On the right side that this is the centrifugal broadcaster was fabricated 3D printer technology, and gear motor, servo motor and all fixed in the centrifugal broadcaster. So and also the existing UV sprayer was the structure was not suitable for the air broadcast attachment, and we made aluminum material supporting frame along with landing gear, and also mounting plate for battery, LiPo battery. And also provision made for easy refilling of seeds or fertilizer, like a UV clamp provided easy refilling. So this is power supply system. So this wireless flow control system provided, like a left side picture is showed that the servo motor when rotating in counterclockwise direction again is completely closed. So when servo motor is rotating clockwise direction again flow rate will be starting, and the grains will start flow from hopper to the broadcaster and again it will the flow. So this is a different view, front view and the side view of how the broadcast attachment to the UAV vehicle. So this is a complete view of UAV developed air broadcaster. This is existing drone vehicle, and this hopper, this control system, and this is air broadcaster, this supporting plate along with landing gear. So this is the complete specification of developed aerial broadcaster. So it's having 10 kg payload capacity. So then after developed, then optimized, calibrated the aerial broadcast in the laboratory for different exposure length and different discharge rate and flow rate for different exposure. And optimized the operational parameters of aerial broadcaster in the laboratory. So ASAP standard, two standard methods followed for the aerial broadcast optimizing the operational parameters like spread width, then throughput capacity, and application rate and all. So this is a one standard for the stationary calibration. Once this is like a spreading for optimizing the broadcaster speed, like how much speed you have to follow, whether it is minimum or medium or maximum. So again, this is a view of how the seeds are collected in the cockpit tray. So that this is another one movie condition. Previous in the station television, another one is that area like a movie condition for optimizing the of the forward speed and exposure length. So we got best recommended application rate with 3 meter per second
and 10 mm exposure length. So this is the views of how we optimize the operation parameters. So this is the blue sticky cord we placed on the track and operated with 2, 3, 4 meter per second, and the sticky cord projected sticked on the sticky cord. So these are the results of we got the optimized recommended application at clearly 100 kg per hectare. So at 3 meter per second speed at 12 mm exposure length. So this optimizing the operation in the laboratory, then evaluated in the field condition. So this is the view of in wetland condition. The field was prepared with fertile. So this is the pictures of how the during the operation in the during air broadcasting after 21 days the crop view, and comparison with manual and evaluated, and we got more uniform distribution in the area broadcasting field. This is one small video. So field of states in the copper. So we did aerial broadcasting in the Tamil Nadu wetland field condition, and got a best result in 3 meter per second, 3 meter per second at 12 mm exposure length and 1 meter height of broadcasting. So and we demonstrated this technology in the Odisha Agriculture Exhibition. We got best response from the farmers, and also now the MOV is going on in the Tamil Nadu agriculture for popularization. This is conclusion. This customized drone UAV vehicle is used for carrying the three operations: spraying, seeding, and fertilizer. So you can utilize the best utilization of this UAV technology, and also we got better uniform distribution compared to manual method. So it also saves the drudgery where you can using.
But you have not shown anywhere in the data that manual broadcasting and this broadcasting.
So in previous table I shown yes.
Left side जो रहता है
during the area broadcasting time.
मैनुअल का भी रखते तो ये जो डिस्टेंस दिख रहा है ना इससे काफी अंतर है जो मैनुअल करते हैं ना ब्रॉडकास्टिंग जो ट्रेडिशनल पर्संस who are doing it is a skilled job.
Yes sir.
Skilled persons used to broadcast manually. So this method spacing is more if you see then that will be
but my only suggestion is for regular paddy sowing or this transplant, this method should not be. This should be only recommended for those wetlands where nothing can enter. There you can, like on even wet marshy lands condition well, or the even you having areas like heart of
where operation is very difficult.
You cannot go.
Cannot go.
You want only grass to grow, or you want to grow particular specific type of crops.
Breeding and other things is again the same problem which we have taken. Yeah, next, Dr. Ravi Kumar.
I acknowledge the thanks to ICS, VAE,
Is your permission? I want to ask one question. That the discharge rate of the seed is proportional to the farmer speed or it is constant during the operation?
No, we constant one fixed during the before operation only sir. Because optimization in the laboratory condition only sir. Like how much exposure rate and how much forward speed, that one fixed only sir. Then fixed operation parameters only in the field conditions.
After concluding statistical data
उनको कई चीजें का लोग नहीं कर रहे और मुझे जो होना चाहिए वो नहीं आता थोड़ी एनर्जी को भी प्रोवाइड करके
energy waste of submarine monitoring meter for a hectare. So background of the developed technology, the energy consumption during 30 days of session, the different passes are different by using the same type of the instruments. Suppose first time any tractor is operated after harvesting the wheat or paddies, energy consumption is more, but second pass or third pass energy is less. But the customer is charging is collected the same or approximately based on the time or area coverage. That's why we developed a system as per the customer consumption of the energy based on customer charges will be collected. So where the customer charges are collected based on the area base, develop customer monitoring meter, calculate the customer charges based on the actual energy consumed during the agricultural operations. Sometimes the driver saves some amount of the diesel by operating the implement. Just introduction and diesel transient. Save some amount of the diesel by operating the instrument in the shallow depth. Also hide some diesel or money from the owner. So that's why tracking is needed. So objective of this invention is the proposed monitoring meter will facilitate the accountability in the customer provider and the farmer, and will get the required benefit for the price paid by the farmer. Tractor can be easily monitored by using the meter remotely by customer center and the tractor owner. Tractor driver will operate the tractor at the optimum depth and consequently increase the productivity of the land. So this is the conceptual diagrams. We mounted a fuel meter, and there other factors are also included like time and area. And these are there are lot of programming for developments, and there are lot of factors included. That's whatever the doing the development support that we say here. And this is also the IoT based because that data is transferred to the cloud and received by the owner on mobile. So there is need of one mobile app is developed which is installed in the owner mobile. And trend of the energy is also displayed in the graph plot. So we developed this is the approximately 800 line program. This is the cloud. Google Cloud is used here. This is our app developed data. Some of the GPS is also installed here. So track our tractor where it is operated. And this our objective is tested with this developed technology in the IRA field. We see the different depth. Fuel consumption is different and the sleep is different. So after finalizing we also customized PCB is developed. This is the controller of this. So that is the conclusion. We developed this customizing monitoring meter. Say their price approximately hardware price is approximately 25,000. So.
Okay, thank you. Dr. Thambai,
we are aware that right now on John Deere tractor JD system is
No sir, we have used that.
Also you can remotely track the tractor, how much area it has covered, what is condition of that tractor,
Sir, we know that nowadays Ola Uber is based on the distance, but in our technical system, energy is important. That's why we are
energy calculation you may have done on the basis of fuel consumption.
Fuel consumption, time and area, three factors we have included.
What that fellow was really doing with fuel consumption meter. It will vary with according to your tractor model, and it will.
So we have included the sophisticated fuel meter, not like a plastic car.
Good evening to all of you. I am going to present product practice of PV-based
spraying system cotton crop. Directly come to material method. Actually, cotton crop height was very big, and at that time it is very difficult to move tractor inside the crops, and also manual spraying is very problematic. So at that time, drone spraying system used to solve the problem of white fly on the cotton crop. So this is the experimental plot. We have taken crop variety Ajit type, and before conducting the experiment, we have collected weather data. Weather data is very important to conduct the experiment of drone, because wind speed, pressure, humidity also affected the performance of the droplet characteristics. So we have conducted experiment and also collected the wind speed, air pressure, humidity. So in our study we have considered 6 hexacopter spraying drone, 10 meter capacity. These are the statistical design plant. We have taken height of operation, speed of operation, application rate, and leaf surface area, axial. It is a very important thing. Sometimes insects is hidden below the surface of the leaf. So we have mounted water sensor at top surface and bottom surface, axial and axial surface of the leaves, and we have the optimized spraying parameter and this dependent parameter spray coverage, droplet velocity, droplet size, and diffusion criteria. So for this we have mounted this is the water sensor top surface of the leaf and bottom surface of the leaf. These are the water sensor mounted in different part of the crop, top, middle, and bottom, and we have added this drone spraying system in this crop, cotton crop, and we find out the droplet characteristics on this. So these are the different plant section, axial and top section, bottom section, and which images appear to analyze the droplet characteristics of the drone. And we have also used the gray wood optimize artificial neural network technique to optimize the operational parameter. And these are the some invertible. In this we consider the working height of working speed and 5% significant level of significance. And these are the some crop. These are the curve effect of the working height, speed, and these are that on the percentage coverage. This deposition and droplet density. These are also on the different working parameter. And these are optimized parameter means when our operating drone, then height of operation is 1.5 meter and speed of operation 3.13, and these are the 2 meter per meter. And after operation of the nutrient, we have also kind of the what is the efficacy of the nutrient we have used. For this purpose, we use the multi-spectral sensor for kind of the vegetative indexes. Means kind of the what is the before operation, what is the vegetative index, and after operation, what is the vegetative index. So yeah, so for this we have operated drone in autonomous mode. And these are the conclusion. See, droplet characteristics of human spraying system were significantly affected by 5% of level of significance at a different operating parameter, and our operating parameter is optimized parameter is 1 meter height, and 3.1 meter speed, and meter meter per second of the estimate. We have also published one paper in this measurement journal that last article 11.6 rating. We have also published status paper and some book chapter and also article, and to time considered in formatting SOP, VIS standard, everything, same college marketing, also data is. Thank you.
Thank you, Chandeep. डॉक्टर संदीप 2 मिनट में कितना बढ़िया बता सकते हो Now challenge with 2 minutes how best you can convince the house.
Good evening to all of you. My topic is development applications where we try to implement system for field graph. There are number of fertilizer applicators available developed in the India as well as aircraft, but they are based on the map-based approach or as well as sensor-based approach. So, but there is a lot of limitations in the sensor-based approach they are developed in the India. So, we are also trying to develop a camera-based fertilizer system for field graph. So, this is a complete methodology for our system. We conduct the experiment that capture the image and run the different models, and finalized model be uploaded in the hardware in the microcontroller, and microcontroller actuate the hardware system, and finally it is in the field. These are methodologies. So we conduct the experiment in wheat crop as well as paddy crops, and collected the same color image of each graph in different category. And these are algorithm to remove the background of the image, and these are conducted that optimize two different deep learning models, that Google and LSI model, and tune this model with different epoch size, batch size, dropout layer, solver, and learning rate. So we optimize that finally based on these parameters we select the model, and we find out that these are 10 input size and 20 batch size, and these models will perform well for both graph. So finally these are performance of different models, and these are the final models, and the result for each graph Boolean model shows the accuracy of 94%, and the external model shows more higher accuracy for both graphs. So we select an XR model for final uploading in the .html file created, and this file will be uploaded in the by microcontroller. So these are the components for development of the fertilizer system. These are the transformer system. These are the file systems that we tested in the paddy graph as well as the wheat graph. These are the shows that this graph is low stress level, medium stress level, high stress level. Based on that stress level, the system has applied the fertilizer in liquid form and in the granule form. We are showing that liquid applications by using nano urea combinations, and ultimately we measure the NDVI value based on that recommendations, how much NDVI value is up, and at what level this will reach a uniform NDVI value in all the different kind of treatments. These are our development. This is system we developed in a Mechanization type variable fertilizer system we developed here based on the different deep learning models, and finally we approach this system.
Thank you. Very good question. Mr. Naveen. नवीन नहीं गोपाल, डॉक्टर गोपाल। अच्छा संदीप पांडे जी भी हैं क्या यहाँ? नहीं। दोनों आप ही करोगे? ऑनलाइन। ऑनलाइन पैसा लिया ऑनलाइन लास्ट
I'm presenting my PhD work here, that is development and evaluation of the variable rate sprayer for with LIDAR integrated technology for mango orchards basically. So I will go directly to the brief outline of the work. So by LIDAR, why we use the LIDAR sensor? Because it is a weather focused sensor, and it has very high measurement capacity. Around 1000 to 8000 points per second it has the capacity of measurement. So we have used that LIDAR sensor, and with one limitation with the LIDAR sensor is that too many points are there. So processing of that too many points and estimation something canopy parameters from that much data is very difficult. So that is our work estimate. So we have developed an algorithm to estimate the canopy volume by separating the non-core crop parameters from the background, and basically estimating the canopy volume in 3 different zones. So this is the algorithm we have developed. I will go directly to the results. So we have used 3 scanning periods in the orchards, 0.5, 1, 1.5 and 2 seconds. So basically for 1.5 seconds of scanning in the LIDAR orchards, we have got the best mean absolute error, that is 2.1, 2.8, and let's go directly to the video. So we can see that there are three different zones in the canopy, in the vertical canopy. So upper, lower and the middle. So middle canopy has the most of the volume, and the lower and the upper canopy has the least of the volume. So basically the sprayer is spraying at the highest volume in the middle zone, and whenever there is enough canopy, all of the 3 zones will be non-sprayed. So that is basically this sprayer will save 52.8 or around approximately 53% of the chemical sprayed in the mango orchards.
Thank you. Dr. Sani.
We will begin the 100% here. This presentation is on efficacy of UV-based spraying system for nano-urea application in maize crop. I will come to directly in this first part of the study. And as you know, like with all the parameters in drone spraying, we are going up to height of like 3 meters and spraying pressures in the nozzles are varying from like 0.5 kg per centimeter square to 5 kg per centimeter square, which is 49 to 490 kVA. So I have taken like 10 pressures, 2 nozzles, which possible nozzles are used in the drones, and 10 heights to see, to answer a question that whether the height, when we spray drones, height or pressures, which we are operating in the drones, have effect on droplet size. Whether varying these, whether the droplet size is under recommendation of ASAB. So we did that study and we have developed a lab setup to do that with varying height, and we have used droplet size analyzer, and we found that with all the pressures, with flat film nozzles and both the nozzles, that mostly the sizes are within the fine to fine medium zone. So the conclusion part of this that for both the nozzles we can go ahead with pesticide use at any, the recommended height up to 3 meters and the pressure is up to 490 kPa. And furthermore, we found that the increase in operating pressure, the droplet size found to be reduced, and when we increase height, the droplet size were found to be increasing, maybe because when it is coming down, because of cohesive force, some of the droplets converge. The other parts of the study is like in the laboratory, we wanted to optimize the operation. So we took 3 speeds, 3 propeller speed of operation, and 3 discharge and top 2 zones, and we arranged randomly, and then we found 2 top and bottom zones of the what is it, we put and analyzed, and we found that for the coverage for flow rate it is affecting significantly, but in the zone of 1.2 to 2 liter per minute. So for the field study we took this zone only, this range. And for coverage and propeller speed doesn't affect much in the selected zone. For the forward speed also between 2.5 to 5 km per hour, which is around like 2 meters per second, or nearby, it's not affecting much. The zones are affecting. Now we analyzed, and we found that the similar results were found for deposition and deposits, that is number of droplets per centimeter square. We found that flow rate and conversion significantly affected droplet characteristics. And these parameters, we went to the field, we divided the field into 3 particular zones. We divided 3 zones like broadcasting pre-urea, drones, and gun sprayers, and we did the trials. We measured NDVI value and SPAT value, NDVI with green figure and SPAT value with SPAT meter, and we divided the 0.5 acre area into 26 subplots, and we collected, before spraying we collected data, and after 8 days after spraying or applying nitrogen fertilizer we collected urea, and we found that in the pre-urea zone, and then in pre-urea zone, and then drone sprayed with nano-urea and gun sprayed with nano-urea. So we found that these two nano-urea treatment, like drone sprayed and gun sprayed, is performing similar. No, there were no difference, but the values are like SPAT value were increased for pre-urea after 8 days of spraying and broadcasting, and NDVI reduced for these 2 treatments. Thank you so much. This is my conclusion. Like for all this. For all the nozzles, like both the type of nozzles, the operated, when we operated, we found that it is under the recommendation, and for droplet characteristic in laboratory, flow rate and canopy zones significantly affected performance, others not. And then for drone efficacy evaluation, drone sprayer performs similar to gun sprayer. Thank you so much.
Thank you very much.
We have completed 18 offline out of 31 plus one read lecture. 19. One is online. Dr. Himanshu Pandey. Himanshu naam? Himanshu Dr. Pandey. Dr. Pandey, are you?
Yes,
Yeah. So, you will start sharing. You have 1 minute extra, so 3 minutes. You will start.
So, good evening to us. I'm going to on So, as we are about greenhouse gases emissions and the impact on environment, so there are 3 major greenhouse gases that contribute to the total global warming. And apart from this, agriculture also is part of the greenhouse emitting source that emit a portion of the gases due to soil respiration. So, due to the storage and emission of that soil is large, so proper quantification is needed for that gas. So, for that, there is different methodology has been developed and used for the quantifying these gases. So, mostly they take the samples from the field and they go further laboratory analysis. But nowadays we can see the advancement of sensors. There are so many sensors are available in case of cancer as well. So that can be used to get the number of data in the real time field condition for the greenhouse gas. These are the concept for the measure of greenhouse gas of the gas analyzing system as well as the chamber system. So whatever the gas being emitted to the from particular chamber, that can be processed for the control and then by the gas sensor that can be in the real time with the help of the lobby system. So this is the CAD model and drawing of the developed system. And this is the system that has been installed in the field. It consists of the Arduino maker and NDI-based CO2 sensor, methane sensor, and N2 gas sensor. And the flat chamber that has been consists of the 500 mm of the diameter. And also we have used a diaphragm pump to transfer the sample that has been collected into the chamber to the gas analyzing system. So where this is the gas analyzing system where all the sensors are installed, where the microcontroller and breadboard and the same when the gas sample collected in the chamber that has been transferred to the gas analysis system, where the gas sensor based on the concentration between lasers and that process with the help of the program and that can be seen to the display in the field in the real time. So this is the circuit diagram where all the sensors and the other components are integrated and this is the complete system with all the components. It has a 12-volt battery and pump for the transfer of gas samples from the samples to the gas system and then chamber and then to the data logging system where we can get the data. So first of all we have calculated the sensors for the different concentration gas concentration. We start from the medium with the developed system and that sample has been calculated with the DC as well as the standard gas concentration. So these are some calculations that we use for the concentration for the gas sensor. These are the calculation models that can be used for the calculation of methane gas sensor. So this is the calibrating gas cylinder sample that has been procured and that sample has been injected into the gas mixing chamber where we have kept the gas sensor and for different concentration levels we have calibrated that and that sample also checked with the available gas DC. So we got a linear relationship between the standard gas concentration of the developed system as well as the sample.
Go to the conclusion.
So this is the result of that laboratory study. So for accuracy, it has been found that 85 to 96% with average of 93% of CO2 plus measurement system, and we can measure the gas from 0 to 10,000 ppm. And where the CH4 gas sensor that exhibits around 91% accuracy with the DC, but at a high concentration level, but at lower it has less accuracy observed. So for further calibration by using the algorithm is under progress. And there are some use of the field data measurement in the data. And this is the same finding of the work that sensor sensitivity showing the data responsive at a high concentration. The CO2 sensor must be a high accuracy and responsive for monitoring of CO2 concentration. However, the CH4 sensor shows the low sensitivity, particularly for lower concentration level. So the overall data system is formed more responsive for CO2 as the system. And we talk about the cost of the system, it will be around 1 lakh.
Okay, thank you, Dr. Mande.
Hello, good evening, sir.
Myself, Mr.
Yeah.
Good evening, sir. Myself, engineer Naresh.
हम शेयर करिए भाई पांडे जी हाँ तो you want to present?
Yes, sir.
So within 2 minutes if you can, because our all the cultural program everything is running.
I also want to present, sir.
Okay, so please present. Not more than 2 minutes.
अरे सर मैं प्रेजेंट करता हूँ Good evening all of you. My topic is image-based food detection and robotic harvesting. It's a comprehensive review of both. So, shortage at the time of harvesting of fruit, the shortage of farm workers are at its peak, and it's lead to the delayed harvesting that further cost to the 30% of the losses, up to 30% of the losses globally. So, robotic harvesting or deep learning based fruit detection method can solve this problem. So, there can be 4 types of fruit detection techniques. That is one bounding box, and further it's improved version of segmentic detection, instant detection, and fourth one is a key point detection for the one type of the fruits.
अरे भाई किशन कुमार आप फाइनलिंग पर जाओ सीधे तो ये तो क्या है रिव्यू है ना फाइंडिंग में क्या पाए हो बताओ बस लास्ट स्लाइड से एक स्लाइड पहले तो मत करो
Okay, sir. So, fruit detection and tokenized method based on deep learning is used for accurate, fast, and robust fruit detection and tokenization. But the ability of accurate detect, locate, and access the ripeness of the fruit is complex and dynamically changing environment remains a challenging task for the robotic harvesting. And its limitation is high quality of data sets, image detection of the small target fruit, different varieties, and fruit image in the lightweight condition. That is the challenge. And the robot is also require a robust navigation system for the in the field for complete harvesting in the overall.
Thank you, Mr. Kishan Kumar. Next one है अपनी जगह से आपको सर्टिफिकेट मिलेगा अगला कौन है
I am ready for presentation, sir.
तो शुरू हो जाओ बोल के कंप्यूटर पे बैठे हो
So, very good evening, sir. So, my presentation topic is development of remote control for battery power ground vehicles, specifically EV4 trains. So, first of all, introduction to agriculture is a major source of income for the Indian.
भाई आपने जो काम किया वो बता इंट्रोडक्शन छोड़ो तो नाम से पता चल जाता है यार इतना लोगों को पता है आगे चलो
So, this is the application sir due to the dynamic of pesticide being processed. The workers are exposed to chemicals. This is very hazardous. That creates cases of malaria, respiratory disorders, and vision problems. And annually around 3 lakh deaths occur every year in the world.
भाई नरेश जी आप अपना जो काम किए उसको बताओ देखो टाइम मत खराब करो
So this is the conceptual view for spraying, remotely controlled spraying vehicle that is designed in using efficiency 60 software. And this is a new developed ground vehicle that is mainly consists of hose, part, propelling unit, steering system, radio frequency range, wireless remote control system, and a power supply unit. And this vehicle has both of the option vertical as well as horizontal boom attachment. So there is a power transmission system of this ground vehicle. We having overall gear reduction system. And these are the basic this ground vehicle. We have used a 100-watt BLDC motor. BLDC motor controller, linear actuator for controlling the steering system, and radio transmitter and this for wireless control of this vehicle. And the battery of 48 volt battery as a power source for this vehicle. So this is the circuit diagram of the.
हेलो नरेश।
हाँ जी सर।
अरे भाई आप वीडियो है तो कोई दिखा दो, हम लोग समझ जाएंगे। बहुत यहाँ है उतना समझने लायक तो नहीं है। आप कंक्लूजन स्लाइड में जाओ, वीडियो होके दिखा दो बस, आपको सर्टिफिकेट मिल जाएगा।
So this is the performance of remote control. We have actually we have now in this we have developed ground vehicle for mounting the spraying system on this vehicle and evaluating the performance of this vehicle. It is effectively controlled with the remote controller. The vehicle maximum speed is 6.9 km per hour and the range is 3.5 meter and the ground clearance of 70 km. Its fragments is also kept at a level 1 to 1.6 meters. And the conclusion is that this vehicle will help to minimize the operator's contact with the hazardous agrochemicals. It is equipped with vertical horizontal boom, and this paper nozzle position will help to spraying in different crop conditions. And we will fix individual nozzle-based actuation system on this vehicle, and developed ground vehicle can also be used for as a prime mover for other agricultural machines. So I think you play.
आगे कौन है भाई? और कौन है? Anybody else? Online?
Yes sir, Dr. Ganesh is here.
चलो भाई हो गया, देख लिया आपका। अगला कौन है?
गणेश होगा ना? गणेश उपाध्याय।
गणेश उपाध्याय। अरे भाई नाम तो यार उसका था कहीं।
हेलो।
हाँ सुनाओ भाई आप भी।
यस सर।
गणेश जी आप यार करिए।
यस सर। आई एम प्रेजेंटिंग।
गणेश तो हमारे उसका है, एफआईएल सेक्शन वाला।
सर इज माय स्लाइड विजिबल?
नहीं विजुअल नहीं है, आप भी विजुअल नहीं हो बस।
वो मेरे स्लाइड पे है।
Okay, sir. So that the topic of my presentation is effect of flight speed and flight height on square position parameters in cotton crop using a drone spray. So I will make time in the introduction. So we have conducted this experiment in the research farm of the cotton section in Haryana Agricultural University. We have varied the flight speed and height at 3 levels, and we have also compared the data with the tractor operated drone spray and the spray. So for the testing, we have used a drone having tank capacity of 10 liter and having a spray width of 3.8 meter and 4 nozzles, and the water sensitive papers were placed at two sides at abaxial and adaxial top leaves at 3 positions of the plant, that is top, middle and bottom, and we used image software to analyze these water sensitive papers and quantify the different spray performance parameters. So these are the results. These are the crop and weather related parameters that we have noted, and these are the different values of droplet density, leaf area coverage and volume of surface position. Here we have found both these parameters affect these spray performance parameters significantly. However, the parameters such as number median diameter, volume median diameter and uniformity coefficient were not found to be significantly affected by the parameters. These values were found to be in this range that is given here. When we have compared the data with the boom spray and knapsack sprayer, we have found that around 62% reduction in droplet density with the help of using drone sprayer we have found compared to boom sprayer, and around 32% in knapsack sprayer. So all these three parameters, least area coverage and volume of spray position, we have found a significant reduction in the spray deposition parameters in this range. However, the value of droplet size was found to be in the lower range with the use of drone sprayer, and uniformity coefficient was found close to 1, which indicates better uniformity in spray deposition. And when we have compared the bioefficacy data of this one chemical chronic amide 50% WG against whitefly and desert, so we found this type of trend. Before the data shows before spray the population of whitefly, 1 day after showing 3 days, 7 days and 10 days, and this is the mean of these 10 days.
आप कंक्लूजन में जाइए, 3 4 5 बहुत हम लोग सुन लिए, आगे कंक्लूजन में क्या है आपको बताओ।
So we have found that all the parameters, flight speed and flight speed, significantly affect the spray deposition parameters, but the NMD and GMD was not found to be significantly affected by the parameters. However, drone sprayer was found to have better uniformity in droplet size as compared to both these sprayers, and there was about 94 and 65% less spray deposition in case of drone sprayer as compared to boom and knapsack. And with respect to bioefficacy, all these sprayers were found to significantly affect the bioefficacy. However, the best control against whitefly and desert was achieved with boom sprayer followed by knapsack and boom.
Thank you. और कोई है भाई? Hello, anyone? Online? Anyone online? If no, so Dr. Bimal साहब, Dr. Engineer Junior साहब, आपको कुछ मैसेज देना है तो आप दे सकते हैं, जो लोग बचे हैं कम से कम, before concluding.
मैं सिर्फ ये बोलूँगा, some ideas were very encouraging. I asked one or two questions also on that. बस मैं एक ही चीज़ बोलूँगा that whatever we are doing, if we are doing it for field adoption, so have a cost target in your product. Otherwise, this research, ठीक है, academic के लिए तो अच्छी है, it will never see the light of implementation. Cost target, हम अगर कोई ट्रैक्टर बनाते हैं ना, तो ट्रैक्टर बनाने से पहले भी डिसाइड किए कितने लाख का होगा, या कोई इंस्ट्रूमेंट, अदरवाइज या कोई सॉल्यूशन जैसे एक ने बनाया 25,000 का बना दिया, जो भी आप बना रहे हो, if the cost is not matching, and spend time on that as well. एक हो गया problem statement of the field, second is adoption का जो cost आ रहा है, वो इसके बाद आप solution निकालो, that will always be better. That's it. Otherwise, I found at least 2 or 3 of the products very nice products. तो जो बोला था ना, जो crawler type का जो बनाया था, that can be an interesting thing if it has life. It can work in monsoon. जब बारिश हो रही है तब वो चल सकता है, deep sea because wetland में चलना है, then it is good. Dryland में भी एक solution. Dryland में आपका जरूरत नहीं पड़ेगा because it can only do one purpose. छोटा ट्रैक्टर जो होता है, it can do 200 purposes. वो उसका तार भी है, वो उसका पंप भी चलाता है, वो सब कुछ करता है. So just think of it. And otherwise, I enjoyed a lot. Of course, it is a little late. We could have spent more time. मैं तो सबसे यही कह रहा था. This I had come for this session just to tell you. सारे लोग चले गए, मैं आज इसलिए आया था कि I would.
Next time we will try to schedule this session first.
Yes. Thank you.
I requested first only, but
we also want to hear some suggestion for the investor by your director.
Yes, session complete हो गया.
अरे आप 2 मिनट आप भी कुछ आशीर्वाद दीजिए.
Yeah, actually this session is one of the most important sessions in the present context. I think this session
all the presentations, or most of the presentations were very good.
Yes.
But
No,
we
no.
wanted to interact, but due to shortage of time, we could not interact also. So I compliment all the presenters for doing good work, as well as presenting it in a short time also. And next time, we will try to have this schedule, this session first, and then we will have delay interaction. The session in which accommodate only a few scientists are working in that area. So this is only for now.
So thank you, sir, and thanks. I also thank all the presenters. Total 18 offline and 4 online. So 22 out of maybe number. It was very good presentation. I will also endorse totally Mehta sir, and I also thank our director. Dr. Senthil Kumar for giving me opportunity, and initially we have Indramani sir, who has also thrown light on this topic. So thank you all.
Okay, thank you, sir. So at the end, I would like to thank both the chairpersons, Dr. Indramani sir, Honorable Vice Chancellor, and Dr. S.P. Singh, Project Coordinator, AACRPR, Animal Husbandry Mechanization, and 2 reporters, Dr. Ashdod Pandirwar and H.S. Pandey. So I thank all of them. So with momentum, please. So tomorrow session starts by 8:30. The subject is economics. So all of the presenters, please come by 8:30. So we have to start by 8:30, and then we have to finish it by 9:30. So all are requested to be here 8:30 and load your presentations. Okay, thank you very much. Thank you. Have a nice time. Good night.